All right, welcome to section 14.7, maximum and minimum value, local max and local min. Okay. So here come from calculus 1. Oh. In order to find a local max or min of a function, what do we do? We just have to find the point in which the slope of the tangent is 0. In this class, we do the same thing. Well, we don't have one derivative, but then we have two derivatives. That is, we set fx equal to 0 and fy equal to 0. The solution to the two equations is a point AB in the domain of fxy. We call this point the critical point. So in this class, the same occurrence happen. Okay, so here comes the surface. Let's see. Look at this thing here. This surface here, it looks like a horse saddle, right? So that's why we call it a saddle point. To determine whether a critical point xy used local min max or saddle. We use the second derivative test. Let D equal the determinant of this matrix here. Fxx, Fxy, Fyx, Fyy. Well, we just call it the Hessian matrix. Well, the determinant is the Fxx fyy minus fxy fy extra Clairaut theorem, which say that fxy is the same as fyx, and this would give us the fxx fyy minus fxy square. Yeah. So let this be d. Well, we have a bunch of cases if d is more than 0 and fxx ab is more than 0, then fab is a local mean. You can treat this thing like a concavity of surfaces. If d is more than 0 and fxx ab is less than 0, it's concave up, concave down, then fab is a local max. Well, if d is less than 0, then fab is a saddle point. And then the reason why we want the determinant to be more than 0 is to this thing here, right? To ensure the surface has the same behavior. For all points near AB. That is, all points near AB either rise or fall. Yeah. Find the local max min and set a point up. Up. Fxy, don't know if we have time to do two. We'll see. X to the 4 plus y to the 4th minus 4xy plus 1. So step 1. Find all critical point. Well, to find our critical point, we're going to set fx, that is the 4x to the 3 minus 4y, set equal to 0. And then remember, you can have a system of two equations. Make sure you solve both of them, right? We also have a fy is equal to 4y to the 3 minus 4x, right? You set it equal to 0. What do we have here? What happened here is going to be a y equal x to the 3. And what do we have here? Well, for this one, you can do the substitution. Remember, you are solving for a system of these two equations, right? You have two equations, two unknown. I should be able to solve for x and y. This one, I'm going to sub y equal x to the 3. 4 x to the 3 minus 4x equal to 0. From here, don't do x to the 6, guys, because you don't add them up, you multiply them. So I'm going to do 4x to the 9 minus 4x equals 0. Then we're going to have to factor this thing out. You can drop the 4 here. Right? Let's make your life similar. X to the 4 plus 1, x squared plus 1, x squared minus 1. X to the 4 plus 1, x squared plus 1, x plus 1, x minus 1. Okay, we have a x equals 0, right? X equals -1, x equals 1, 3 real root. Oh, we want to get the point AP. AP, remember, so we got to get the y value. At x equals 0, y equal to 0 to the power 3 equals 0. Right? So you get 0, 0, right? 1 point. X equal 1, y equal 1 to the 3, 1 on 1. X equal -1, y equal -1 to the power 3, -1. Minus 1, minus 1. Right? So these are the critical points, 3 of them. So that is step 1. Right? Next, we're going to move on to the step 2. That is, we're going to be using the second derivative test to determine the nature of each critical point. So step 2, use second derivative test to determine nature of each critical point. D is the fxx fyy minus fxy square. Well, we have fx, so might as well do the fxx there. So it's going to be a 12x squared. Fyy is going to be 12y squared. Fxy is going to be a -4. No, square. So we have a 12 times 12 is 144. X squared y squared minus 10. Okay, so this D. So next we're gonna test out a D at each point here. Now use it to test out each critical point. Okay, I'm gonna do a D of 0, 0. D of 0, 0. If you do it, we're gonna get -16. It's less than 0. Wow, less than 0. Oh, what do we have here? We have a it's the set of point. D11. Well, D11 is going to be 128. It's more than 0. And you got to do, well, if it's more than 0, you got to do a fxx 11. Because it's say right here. say you have to do fxx at the point and see whether it is more than 0 or less than 0. Fxx is 12x squared, so it's going to be a 12. It's more than 0. So more than 0 is concave up, right? Concave up means that f of 1 is you plug in 1 in here, right? What do we have here? 1 so it's -1 is the local mean. D -1 is also 128. It's more than 0. And you got to do f of xx -1. Well, punch it in. We're also gonna have the same thing. So that tells us that f -1 is equal to, well, the cool thing about this function is that you punch it in, you're gonna get the same thing. -1 is the local mean. F, I'm gonna do z here, shortcut my life here. X to the 4 plus y to the 4th minus 4xy plus 1. Oh, very nice. Oh man, you guys can see it. It looks very nice. Oh my God, look at this thing. It does look like a pair of teeth. Column 2. Absolute min max. Similar to calculus 1. If fxy is continuous on a closed and bounded set D, in R2, then f attains an absolute max and an absolute min. Max and an absolute min. To phi D absolute min max. You do a few things here. First thing is phi R critical. Value of f inside D. Remember, the critical value is only on inside, right? Not on the boundary. So and then the second thing is that you got to find all the critical points and end points of the surface on the boundary of D. Phi R extreme value, we call it extreme value, including two things, critical point and end point. That's 10 is gonna get a little difficult quickly. On the boundary of D. See? And then step 3 is just, you compare the value in step 1 and 2. I want you to tell me the extreme value. See whether you can get that. Let fxy equal 2x to the 3 plus y to the 4, where D equal to xy, in which x squared plus y squared less than equal 1. Just do a quick question here. How many extreme value are there? Sketch D here. Well, everybody know D is just a disc, not a circle though. A disc of radius 1. My God, is there a circle here that I can put on here? Yeah. Okay, so it's D. Right. It has two parts. X squared plus y squared less than 1. X squared plus y squared equal 1. So in order to find the extreme value, right? Extreme value include the critical point and end point. So two of them. Careful with this thing here. Boundary D is circle. X squared plus y squared equal 1. And then from here, you can see that y squared is 1 minus x squared. And now you can do the substitution. You're gonna do the sub here. Sub it in, and we're gonna get just a function in terms of x. How nice. A little trick. Okay. And then work it out. So you're gonna get a x to the 4 plus 2x to the 3 minus 2x squared plus 1. Well, You know, x does not go anywhere. Where x can only go from. Look at the circle here. X only go from here to here. -1 to 1. And these are the two endpoints. They will tell you these are the two endpoints. And in order for you to get the critical point, right, you just have to set g prime equal to 0 and solve for x. Well, if you do that, you're gonna get a, you know, luckily in this case, you're gonna have 3 real root. And thus the answer to this one is that how many extreme value are there? Well, there are 5 of them. Right?